in problem 3, we have a binomial distribution. Anytime we have a binomial distribution, we need to make sure that we have these two important values. These are what describe the distribution, give us the shape of it. They're important information that we need. So we need to know our sample size, n, and p, our probability of success. So we know that n is 13 and p equals 0.3. This problem asks us to find the probabilities associated with different values of x. And in part K, we're going to find the mean and standard deviation. Now, when we want to find the probabilities for a binomial distribution, we have two options. We can use a table, which looks like this. You'll find this at the bottom of this worksheet. I've just moved it up here for convenience. Or you can use your calculator. In this video, I'm going to focus on using the table. You can ask your TA if you need help using your calculator to do these problems. Okay, so part A, we want to find the probability that x equals 3. So I'm going to show you how to use a binomial table. So the first thing that we want to do is make sure that our n is the correct value. We're working with a distribution that has n equals 13, so we want to make sure that our table also corresponds to n equals 13, which it does. Next, we're given that p equals 0.3, so we need to just focus on this column here. So I'm actually going to cut my table so that it only goes up to 0.3. This way I won't. Well, it reduces the chance that I'll make mistakes. Okay, so I want to find for part A the probability that x equals 3. So the first thing I'm going to do is notice that the rows correspond to different x values. So this row corresponds to x equals 0. This row corresponds to x equals 1. Well, for part A, I want the probability that x equals 3. So I'm going to look at this row. And I know that p equals 0.3 because I'm given that. So I just want to look at this column always. And so I know that the probability that x equals 3 must be 0.2181. That's how you read a binomial table. It gives you the probability that x equals each of these values here for different values of p. So for p equals 0.3 and x equals 3, I go across from x equals 3 to p equals 0.3, and I find 0.2181. All right. Part B asks me, what's the probability that x is less than 3, strictly less than 3? So now I want to add up some certain probabilities. I want to add up the probability that x is 2 plus the probability that x is 1 plus the probability that x is 0, because those all correspond to x being strictly less than 3. So now I want to add up the probability that x is 2. Well, I go across my row and down the correct column. So I know that the probability that x is 2 is 0.1388. And then the probability that x is 1 is this value here, 0.0540. Again, the reason I'm looking at this column is because I know that p equals 0.3. That was given to me. So then the probability that x is 0 is 0.0097. Oops, running out of space here. Plus 0.0097. So I plug all that into my calculator and I add those up, and I should get 0.2025. All right, let's move to part C. Now I want the probability that x is less than or equal to 3. So you can see in these kinds of problems, you have to be really cognizant of the sign here. You have to look really carefully. The difference between part B and part C is, in part B, we were looking for the probability that x was strictly less than 3. So 2, 1, or 0. Now, in part C, we want the probability that x is less than or equal to 3. So this is equal to the probability that x equals 3. Now we're including 3. Plus the probability that x equals 2. Plus the probability that x equals 1. Plus the probability that x equals 0. So now I just have to add on an extra value, which is the probability that x equals 3. So this is 0.2181 plus all the other probabilities, 0.1388 plus 0.0540 plus 0.0097. If I add all of these up, plug this into my calculator, I should get 0.4206. All right. Now in part D, we want the probability that x is strictly greater, x is greater than or equal to 3. So before, I wanted the probability that x is less than or equal to 3. Now I want the probability that x is greater than or equal to 3. So that's equal to, let me get rid of this here. This is equal to the probability that x equals 3 plus the probability that x equals 4 plus and so on all the way to my maximum value of x, which is 13. So I want to add up the corresponding probabilities. So I want to add up 0.2181 plus 0.2337 plus 0.1803 plus all of these values till I get to the very bottom, to 0.0000. So if I put that all into my calculator, and you want to be careful here, once you're putting in a lot of numbers into your calculator, you want to be really careful that you're keying them all in correctly. So the probability that x is greater than or equal to 3, you should get 0.7975. All right, now let's take a look at part E. Part E, we want almost the same thing as part as part D. Part D, we wanted the probability that x is greater than or equal to 3. Now we just want the probability that x is strictly greater than 3. So it's almost the same, except now we're excluding 3. Because we want the probability that x is strictly greater than 3. So this is equal to the probability that x is 4 plus the probability that x is 5, and so on until we get to 13. So I'll write that out. Probability that x is 4 plus the probability that x is 5 plus all the way to 13. So I add up, all of these highlighted probabilities. Lucky for us, the closer we get to the bottom of the table, the more of them are equal to just 0. So it saves us some adding. So this is equal to 0.1535. Oh no, I'm looking in the wrong column. That's not good. I want to look at the correct column, which is p equals 0.3. So I want to add up, not this value, I want to add up 0.2337 plus 0.1803 plus all the way to the bottom till we get, I'm just going to write out 0.0000. All right. Next, we're having some more fun. Now we want the probability that x is between 3 and 9. So the probability that x is greater than or equal to 3 or less than or equal to 9. So let's highlight those x values. So greater than or equal to 3, less than or equal to 9. So that's these values of x. So the probability that x equals 3 plus the probability that x is 4 plus the probability that x is 5, and so on till I get to 9. So I'll highlight the correct probabilities here. So I want to add up 0.2181 plus 0.2337 plus 0.1803, 0.1030, and so on till I get to 0.0034. Part H is almost the same, except now we're not including 3. We want the probability that x is strictly greater than 3 or less than or equal to 9. So strictly greater than 3, we're going to start at 4 and go up to and including 9. So I'll write that out in words. This is equal to the probability that x is 4 plus the probability that x is 5 plus the probability that x is 6, and so on until we get to x equals 9. Let me highlight those probabilities. So I want to add up 0.2337 plus 0.1803. Add up all of these up to and including 0.0034. For this, you should get, let's see, 0.5787. In part G, you should have gotten 0.7969. All right, let's go to part I. Now, we no longer have any less than or equal to signs. We just have strictly less than signs. So we want the probability that x is strictly greater than 3 or strictly less than 9. So that's these highlighted x values, which correspond to these probabilities. So I'll write this out. This is equal to the probability that x is 4 plus the probability that x is 5 plus the probability that x is 6. I'm going to write them all out. Probability that x is 7 plus the probability that x is 8. So those corresponding probabilities are 0.2337 plus 0.1803 plus 0.1030 plus 0.0442 plus 0.0142. Plug that into your calculator and you should get 0.5754. All right, let's now take a look at part J. Almost there. So here, we now have a less than or equal to sign here, but not here. So we want the probability that x is greater than or equal to 3, but strictly less than 9. So this is the probability that x is 3, 4, 5, 6, 7, or 8. So I'll write that out. Probability that x is 3 plus probability that x is 4 all the way to x equals 8. And I will highlight those probabilities for you here. So you want to add up 0.2181 all the way to 0.0142. And you should get 0.7935. Okay, lastly, for part K, we want to find the mean and standard deviation of our binomial distribution. Remember that for any discrete random variable, the mean of a discrete random variable x is just the expected value of that random variable. And for a binomial distribution, for a binomial random variable, we have a little shortcut. The mean is just n times p. So the expected value equals n times p. We can only use this shortcut when we have a binomial random variable. Keep that in mind. Otherwise, we have to use our formula x times p of x, sum that over all the possible outcomes. This will also work for a binomial random variable, but there's no need to go to all that work when we have our little shortcut here. So we're given n and p here. These are called our parameters. This is equal to 13 times 0.3, which if we plug in to our calculator is 3.9. So the mean of our binomial random variable x is 3.9. That's the average value of x. Okay, next we want to find the standard deviation. So just like the mean of x is equal to expected value. Okay, so just like we have a shortcut for the mean or the expected value, we have a shortcut for the variance for a binomial random variable. So the variance of a binomial random variable is n times p times 1 minus p. So we plug in 13 times 0.3 times 1 minus 0.3. This is equal to 13 times 0.3 times 0.7. So this is equal to, if you plug into your calculator, 2.73. So then lastly, to find the standard deviation of x, we simply take the variance of x, which is equal to the square root. We take the square root of the variance. So we take the square root of 2.73, which will be approximately 1.65. So that tells me that my mean is 3.9 and my standard deviation is 1.65.